Hey everyone, welcome back to my channel. Today we're going to solve previous year questions on units and dimensions, one of the most fundamental topics in physics. Instead of just memorizing formulas, we will understand the concepts, learn smart solving techniques, and discuss the common mistakes students make in exams. By the end of this video, you will be much confident in tackling PYQs from this chapter. So grab your notebook, pause the video whenever you want to solve a question on your own, and then compare your approach with mine. Let's get started with the first PYQ. This is a question from NEET 2025. The question states P is equals to a cube b square upon c root d, and the values of each percentage a, b, c and d are given as 1, 3, 2 and 4. 1, 3, 2 and 4. In this type of question, I already told you in a video that you always write the coefficient first and then multiply it with its percentage. So what's asked in the question is the percentage error in the quantity P. So basically delta P by P percentage would be your 3 times delta A by A percentage plus 2 times delta B by B percentage plus 1 times delta C by C percentage plus half, as it's given in the question as root, so we'll take it as half, times delta D by D percentage. So the values given over here are basically your delta A by A percentage and so on. So delta P by P percentage would be 3 times 1 plus 2 times 3 plus 1 times 2 plus half times 4. So this comes out to be 3 plus 6 plus 2 plus 2. 6 plus 3 is 9 and 2 plus 2 is 4. So 9 plus 4 comes out to be 13%. So the answer to this question would be option number A, 13%. Moving on to the next question. A similar question which came in 2019, where x is equals to a square b raised to half c raised to 1/3 and d cube, and the values given 1%, 2%, 3% and 4%. The same thing is asked over here, maximum percentage of error in the measurement x. So delta x by x percentage would be 2 into 1 plus half into 2 plus 1/3 into 3 plus 3 times 4. This comes out to be 2 plus 1 plus 1 plus 12. This is 4, and 12 plus 4 comes out to be 16%. This is option number A, 16%. This is a question from 2013. As you can see, it's a similar question, so I'll give you guys as a homework. Please do solve this question and mention the answer in the comments. Moving on to the next question. This is from AIPMT 2010. Let's see what's given in the question. A student measures the distance traversed in free fall of a body initially at rest in a given time. He uses this data to estimate g, the acceleration due to gravity, if the maximum percentage errors in the measurements of distance and time are E1 and E2 respectively. The percentage error in the estimation of g is. So what's given in the question is the maximum percentage errors in distance. In distance is E1 and in time is E2. If you know this formula, that time t is equals to under root of 2h by g, where t is your time period, h is your height and g is your acceleration due to gravity. What's asked in the question is percentage error in g. So let's just Rearrange these terms. Let's first square on both sides. T square is equals to 2h by g. We'll take g over there, so g comes out to be 2h upon t square. So this is a similar type of question we get above, like this, and they have just asked us to find delta g by g percentage. So it's simple. Distance is basically your h is your e1, so it would be e1, and you can see your time t has a coefficient 2, so it would be e1 plus 2 times e2. So your answer to the question would be e1 plus 2 e2, which is the option number B, e1 plus 2 e2. Moving on to the next question. This is AIPMT 2008. If the error in the measurement of radius of a sphere is 2%, then the error in the determination of a volume of a sphere will be. You know the formula for volume of a sphere, which is your 4 by 3 pi r cube, where r is your radius. What's asked in the question is delta, wait a second, yeah. What's asked in the question is delta v by v percentage. That would be your 3 times delta r by r percentage. And what's given in the question is the error in the radius is 2%. So this term is basically your 2%. So 3 times 2, which is your 6%. So the answer to this question would be option number D, 6%. Moving on to the next question. NEET 2022 phase 1. The area of a rectangle of length 55.3 meters and breadth 25 meters after rounding off to the value for correct significant digits is. So what's given in the question is your length, that is 55.3 meters, and breadth, which is 25 meters. You know that area of a rectangle is length times breadth, so let's just multiply them. 553 times 25, 5 3s are 15, 25 plus 1 26, 25 plus 2 27, 3 2s are 6, 5 2s are 10, 10 plus 1 11, yeah, 6 plus 6 12, 7 plus 1 8, 3 1, and add a decimal point over here, and it was 55.3. So what students would do in the exam is mark option number C, as they got the answer after multiplying these two numbers. But if you remember, in a session we said that when they say rounding off to the correct significant digits in case of multiplication, you basically see the numbers having the least number of significant figures. As you can see, the breadth, which is 25 meters, has only 2 significant figures. So what will you do is, whatever answer you get, you have to round it off to 2 significant figures. As you can see, your option number D, which is 14 times 10 to the power 2, you can see 14 over here is 2 significant figures, and I told you that anything raised to is never considered as a significant figure. So the answer to this question should be 14 times 10 square, which is your option number D. Okay, moving on to the next question. This is a similar question of significant figures, but in this case you have subtraction. There's no need to solve the subtraction. You know that during subtraction what we do is we round it off to the least decimal places. Okay, so 9.99 minus 0.0099. As you can see, the least decimal places over here is 2. So what your answer should be is your option number A. As you can see, there are only there's only 2 numbers after the decimal place. Okay, so it would be option number A, 9.98. Moving on to the next question. the quantities which have the same dimension as that of a solid angle. I told you solid angle is a complementary angle which is dimensionless. So we need to find such quantities which are dimensionless. Okay, so talking about strain, if you know strain, which is delta L by L, that is change in length from original length, so this is basically dimensionless, because you can see both the terms in the numerator and the denominator are length. If you talk about angle, then angle is basically arc upon length. Arc is itself basically a kind of length, and it's also divided by its same dimension. So yeah, this itself is also dimensionless. So the answer to this question would be option number A, strain and angle. Moving on to the next question. Dimensions of stress are, if you know that wait a second, yeah, if you know that stress if you know stress is equals to force per unit area, and force is mass times acceleration upon area. So mass is basically your m1, acceleration is L1 t minus 2 upon your area, which is L2. So this comes out to be m1 L minus 1 t minus 2, which is the option number C, m1 L minus 1 t minus 2. Moving on to the next question. The dimensions of mu naught epsilon naught raised to minus half r. See, this question should basically come from your EM waves, because in that you study a formula where speed of light is 1 upon under root of mu naught epsilon naught. So you can ignore this question for now, but this came under units and dimensions, so I had to put it over here. And speed of light is your L1 t minus 1. So it's option number C, L1 t minus 1. Moving on to the next question. This is based on a vernier caliper. Suppose its 10 VSD are equal to its 9 MSD. So let's write it over here. 10 VSD is equals to 9 MSD. The least division in the MS, that is the main scale, is 0.1 centimeter, and 0 of the vernier scale is at x is equals to 0.1 centimeter when the jaws of vernier caliper are closed. If the main scale reading for the diameter is 5 centimeter and the number of coinciding vernier division is 8, the measured diameter after 0 error correction is. So basically this is your main scale, this is the vernier scale, and they are saying when the jaws are closed, the 0 of the vernier scale is coinciding with 0.1 centimeter. So this is basically your positive 0 error, and it's given in the question that a positive 0 error is your 0.1 centimeters. And yeah, 1 MSD given in the question is your 0.1 centimeters. So yeah, let's first find our least count. Your least count is your 1 MSD minus 1 VSD, which is 0.1 minus 1 VSD is basically your 9 by 10 into 0.1. So yeah, 1 by 10 minus 9 by 100, which is your 1 by 100, or 0.01 centimeters. So the correct reading would be your main scale reading, which is your 5 centimeters, plus the coinciding division, that is 8 times your least count, and as it was a positive 0 error, so you subtract, so minus 0.1. So it's 5 plus 0.08 minus 0.1, which is 4.9 plus 0.08, which is equals to 4.98, which is option number A, 4.98 centimeters. Moving on to the next question. In a vernier caliper, n plus 1 divisions of the vernier scale coincide with n divisions of the main scale. If 1 MSD represents 0.1 mm, the vernier constant in centimeter is, okay, n plus 1 VSD is equals to n MSD, and 1 MSD is equals to 0.1 mm. They're asking the vernier constant here. Vernier constant is basically your least count, so they're asking least count. They're asking in centimeters, so we'll convert this into centimeter, that is 0.01 centimeter or 1 by 100 centimeter. So yeah, we all know least count is 1 MSD minus 1 VSD, which is 1 by 100 minus, and here 1 VSD would be n upon n plus 1 MSD, and 1 MSD is 1 by 100 centimeters, so minus n upon n plus 1 times 1 by 100. So multiplying this with n plus 1 on both sides, so n plus 1 minus n upon n plus 1 times 100, n will get cut off, and what remain would be 1 upon n plus 1 times 100, which is your option number B, 1 upon 100 times n plus 1. This is a question on screw gauge. The pitch of an error-free screw gauge is 1 mm, and there are 100 divisions on the circular scale. While measuring the diameter, the pitch scale reads 1 mm and 63rd division on the circular scale coincides. The diameter of the wire is, what's given in the question is your pitch, that is equals to 1 millimeters, and number of divisions are 100. The pitch scale reads 1 mm and 63rd division coincides. Okay, let's first find the least count, which is basically your pitch upon number of divisions. So 1 by 100, that is 0.01 millimeters, and the diameter of the wire would be 1 plus, as the 63rd division is coinciding, to 63 times 0.01, that would be 1 plus 0.63, that is 1.63. Okay, now see, the units given are centimeter and meter. This is 1.63 mm, so converting this into centimeter, we get 0.163 centimeter, which is your option number B, 0.163 centimeters. I guess, yeah, there's 2 more questions left, and then we can end this video. A screw gauge gives the following readings when used to measure diameter of a wire. Main scale reading is 0, circular scale reading is 52. Given that 1 mm corresponds to 100, diameter of the wire above data will be. Okay, so this is actually a very easy question. I'll give you this question as an homework. For a hint, I'll say here already the main scale reading is given, so you just have to add this with your vernier scale reading. That would be your zero error times your zero error times the coinciding division, which is 52. Okay, so please comment down whatever answer you get to this question. Okay, moving on to the last question of the day. A screw gauge has least count of 0.01 mm and there are 50 divisions in its circular scale. The pitch is, so we all know that the formula for least count is pitch upon number of divisions. The least count given in the question is 0.01 mm. Pitch is asked and number of divisions are 50. So multiplying this, we get 0.5 mm, which is option number B, 0.5 mm. That's it for today. I hope you found this video useful. Please don't forget to like, subscribe and share it with your friends. Keep learning and I'll see you in the next video. Until then, all the best for your NEET preparation. Bye bye.